What if I told you that the parts most likely to destroy your engine aren't the big expensive ones under the hood? In fact, they're tiny, cheap components that most car owners never replace or even think about. The shocking part? Ignoring just one of these can shorten your engine's life by thousands of miles. In this video, we're breaking down 11 overlooked parts that slowly eat away at your engine. You'll recognize every single one of them, but chances are you've underestimated just how dangerous they really are. Number 1. The overlooked PCV valve. What if the cause of your engine failure was a tiny plastic valve most drivers never notice? It doesn't look threatening, it doesn't make noise, and you'd never think to check it. But that small piece, the positive crankcase ventilation valve, is working every time your engine runs. Its main job is simple. It regulates gases inside the engine by redirecting blow-by gases from the crankcase back into the intake, where they can be safely burned instead of building pressure or releasing into the atmosphere. Here's the problem. Because the PCV valve is so cheap and small, many people assume it doesn't really matter when it fails. That assumption is exactly what makes it dangerous. Once the valve clogs or sticks open, it throws off the delicate balance of pressure inside the crankcase. Instead of venting smoothly, pressure builds up, forcing oil out through seals and gaskets. Over time, those leaks turn into sludge deposits that circulate through the oil system, breaking down lubrication and grinding down engine parts you can't even see. The staggering thing is you can usually buy a new PCV valve for less than a tank of gas, and swapping it out is often a 5-minute job. Yet ignoring it can quietly erode an engine's reliability for years before any warning light glows on your dashboard. And just as hidden gases ruin engines from within, the next overlooked part silently manages your engine's temperature: the thermostat. Number 2. Thermostat. Did you know a part smaller than your hand controls your entire engine's temperature? That tiny piece is the thermostat, and it acts like a switch for your cooling system. Its job is simple but vital. It opens and closes at specific temperatures to control the flow of coolant between the engine and the radiator. Without it, your engine would struggle to reach the proper temperature or, worse, run far too hot. Here's where many drivers get it wrong. If they don't see the temperature needle creeping into the red, they assume the thermostat is just fine. But problems usually start long before any visible signs appear. A thermostat stuck closed traps coolant in the engine, sending temperatures soaring until the metal parts inside expand, flex, and eventually start to warp. On the flip side, a thermostat stuck open keeps the coolant flowing constantly, which prevents the engine from ever warming up properly. These two extremes create very different but equally destructive outcomes. An engine that never warms up right burns more fuel, produces extra emissions, and accelerates wear on internal components because the oil never reaches its optimal viscosity. The reality is this small part rarely draws attention until it fails, and by then the damage is heavy and expensive. Replacing it periodically is cheap insurance against some of the worst failures your engine can face. Now, moving from heat control to timing precision, the next tiny failure can destroy entire engines at once. But before we move on, I would like you to subscribe to the channel and like the video. Number 3, timing belt tensioner. People worry about timing belts, but forget the part that actually keeps them tight in the first place: the tensioner. Without it, the belt would slacken, skip, or even shred far earlier than expected. The tensioner is designed to apply constant, steady pressure that keeps the belt aligned on each pulley, making sure every rotation of the camshaft and crankshaft stay perfectly synchronized. That synchronization is what allows valves to open and close at the exact moment pistons rise and fall. Lose that balance for even a fraction of a second, and the results are catastrophic. The biggest misconception is that as long as you've replaced the belt, you're safe. Many people reuse the old tensioner, assuming a fresh belt won't depend on its condition. The problem is, a worn tensioner pulley can seize or develop rough bearings that no longer roll smoothly. When that happens, the belt slips or jumps one or more teeth, instantly throwing engine timing off. Unlike a belt that slowly frays, a failing tensioner creates sudden, unexpected failure with no gradual warning signs. On interference engines where pistons and valves share close quarters, even a tiny mistiming can cause them to collide. Imagine hardened steel parts smashing into each other at thousands of revolutions per minute. Bent valves, cracked pistons, and often a destroyed cylinder head follow. Replacing it during a belt swap adds relatively little cost, yet it removes the single most common cause of sudden timing failure. From hidden timing disaster to another belt-based risk, the Serpentine Belt. Number 4, Serpentine Belt. What if every vital system in your car, charging, cooling, steering, relied on a single rubber belt? That's exactly what the Serpentine Belt does. Unlike the old setups that used multiple belts for different accessories, today's engines depend on just one long belt to spin the alternator, power steering pump, water pump, and even the air conditioning compressor. Without it, every one of those systems stops working the moment the belt does. Most people assume they'll see cracks or frays on the surface before the Serpentine Belt gives out. That was true with older belts made of neoprene that age in a visible way. Modern belts, usually made from EPDM rubber, are designed to be more durable. But here's the problem. They often fail internally before any external wear shows. So while the belt might look fine when you glance under the hood, the ribs can separate or the material can shear apart with little to no warning. When that happens, the results are immediate. A broken Serpentine belt cuts power to the alternator, which means your battery drains in minutes. That's why a belt costing around $50 can actually save thousands in repairs and towing costs. Waiting until it breaks isn't just inconvenient, it eliminates critical functions all at once. But while this belt drives everything on the outside, damage can also start deep inside with a neglected fuel filter. Number 5, fuel filter. Dirty fuel doesn't just waste gas, it destroys injectors and engines from the inside. That damage often starts with a single overlooked part, the fuel filter. Every drop of gas or diesel going into your engine passes through it. Its role is straightforward: trap rust, dirt, or microscopic particles floating in the fuel so that only clean liquid reaches the injectors. Without it, those contaminants flow straight into the most precise and fragile parts of the fuel system. The issue is that many drivers don't think about the fuel filter until their car feels sluggish, stumbles under acceleration, or refuses to start. By that point, the filter has been so clogged that fuel flow is restricted, starving the engine. Worse, if the element inside begins to break down or becomes overloaded, debris sneaks past the filter altogether. Once inside the system, those particles act like tiny blades scraping through injector nozzles or lodging inside the pump's moving parts. Contrast that reality with the cost of simply changing the filter. For many vehicles, it's less than an hour of work, and the price of the part is a fraction of one injector. A fresh filter restores proper pressure and keeps the entire system safe. Ignoring it, however, sets off a chain reaction of invisible but costly damage. While fuel filters protect injectors, air filters protect your combustion, but equally ignored. Number 6, engine air filter. Imagine breathing through a dust-filled mass and expecting peak performance. Your engine faces the same struggle every time the air filter is clogged. Without clean air, combustion simply cannot work the way it should. That's because the air filter functions like the lungs of the entire system, pulling in oxygen and screening out the dirt and debris, constantly floating through the atmosphere. Every minute your engine runs, it inhales thousands of gallons of air, and all of it must pass through that single filter. The problem is many drivers reduce the air filter's role to a simple fuel economy issue. They think a dirty filter just means slightly less miles per gallon, so it doesn't feel urgent. But the danger hiding behind that view is much bigger. When a filter gets clogged, pressure inside the intake can force the air to bypass the filtering element. That means fine particles, dust, grit, and even microscopic sand slide straight into the combustion chamber. Once inside, those hard fragments grind into metal like sandpaper, cutting into rings and scratching cylinder walls. Replacing the filter regularly is one of the cheapest ways to stop this hidden wear before it begins. Waiting until airflow feels restricted sacrifices engine health long before performance noticeably suffers. Just like a blocked lung suffocates your body, the next overlooked part regulates your cooling system's pressure. The radiator cap. Number 7, radiator cap. Could a simple $10 cap be the only thing keeping your engine from boiling over? That's exactly what the radiator cap does. It looks insignificant, but its entire design is based on pressure control. By sealing the cooling system and holding in pressure, the cap raises the boiling point of the coolant. Instead of overheating at around 212 degrees, the coolant can now safely handle far higher temperatures, keeping your engine in its safe operating range even on long drives or in heavy traffic. Here's why it's often ignored. Most people think the only thing that matters is whether the radiator and reservoir are filled with coolant. If the liquid is topped off, the cap must be fine, right? Not exactly. The spring and seal inside the radiator cap weaken over time. When that happens, the system can no longer hold proper pressure. Even if there's enough coolant, it will begin boiling earlier than it should, pushing air bubbles into the system and leaving hot spots inside the engine. The lesson here is straightforward. A new radiator cap costs almost nothing and can prevent a runaway overheating event that leads to thousands in repair bills. Underneath that same cooling system lies another overlooked guardian, a sensor so inexpensive, many drivers dismiss it. The coolant temperature sensor. Number 8, coolant temperature sensor. What if the gauge on your dashboard was lying to you? It looks like a simple display, but the accuracy of that needle comes down to a tiny part most people never think about, the coolant temperature sensor. For around $30, this sensor constantly feeds information to both the engine computer and the dashboard. The data controls when cooling fans switch on, how much fuel the engine burns, and what the driver sees on the gauge. In short, it's the messenger for one of the most critical conditions your engine faces. Here's the risk. Almost every driver assumes the dashboard gauge is telling the truth. If it shows normal temperature, the cooling system must be fine, but a failing sensor can quietly distort that reading. When the sensor begins to underreport heat, the gauge continues to hold steady in the safe zone, while the engine itself is creeping toward dangerous temperatures. Because nothing looks wrong, the driver keeps going until the head gasket fails or the aluminum cylinder head warps. By the time smoke pours from under the hood, the hidden problem has already caused massive damage. That's why replacing the coolant temperature sensor at proper intervals isn't wasted money. It gives the engine computer accurate readings, allows fans to switch on at the right time, and prevents catastrophic overheating you'll never see coming. Old lying sensors undermine every other safeguard in the system. Precision and pressure is vital, but suction leaks from vacuum hoses can wreak equal havoc. Number 9, vacuum hoses. Imagine tiny cracks in unseen hoses silently turning your engine into an unreliable mess. Vacuum hoses may look like insignificant rubber tubes, but they act as a network that connects critical components. They control the air and fuel balance, manage sensors, and provide suction to actuators that operate everything from emissions controls to brake boosters. When they're intact, your engine runs smoothly, but once they weaken, all kinds of strange issues begin to surface. The average driver almost never inspects these hoses. They sit tucked away in corners of the engine bay, out of sight and out of mind. Because they don't have moving parts, people assume they last forever. Unfortunately, time, heat, and constant exposure to engine vibrations cause even the best hoses to dry out, grow brittle, and eventually develop tiny cracks. The leaks are rarely visible at first, yet even a pinhole-sized leak can throw off how much air the engine thinks it's getting. Replacing all vacuum hoses periodically is one of the cheapest forms of preventative maintenance. It keeps the fuel-air ratio consistent, helps sensors report correctly, and saves hours of unnecessary diagnostics. Left alone, those invisible leaks keep worsening, draining performance and fuel economy until the engine feels unreliable every drive. From hidden air leaks to hidden oil pressure lies. The oil pressure switch. Number 10, oil pressure switch. Can you trust your oil light on the dashboard? Sometimes it's lying to you. The light that most drivers assume is their last line of defense against engine damage actually depends on a small part that often gets overlooked, the oil pressure switch. This switch measures the pressure inside the lubrication system and sends that reading to your gauge or warning light. When pressure drops below a safe level, it's supposed to signal the driver instantly. The problem is, many owners assume the warning light is guaranteed to be accurate in real time. They believe that if the light isn't on, oil pressure must be fine. That confidence can backfire. When the switch begins to fail, two things can happen. It may report false security, keeping the light off while the engine is already starving for oil, or it may swing the other way and trigger warning lights even when the system is working properly. Both situations create unnecessary risk. Either the driver misses catastrophic damage or wastes time and money chasing a problem that doesn't exist. The good news is that this is one of the cheapest components you can service. For around $15, a fresh oil pressure switch ensures the information on your dashboard is trustworthy, giving you the seconds or minutes you need to shut the engine off before disaster. And finally, from hidden oil lies to hidden firepower, the ignition coils and wires that keep combustion alive. Number 11, ignition coils and spark plug wires. How can a weak spark silently chew through your engine? Every time you turn the key, ignition coils and spark plug wires carry the responsibility of transforming battery voltage into the high-energy spark needed to ignite the air-fuel mixture. Without that sudden burst of energy, the mixture doesn't fully burn. Instead of clean combustion, you get wasted fuel, unstable power delivery, and a gradual decline in engine efficiency that's harder to detect than you'd think. Most drivers assume ignition issues are obvious. They expect a misfire, shaking, or a check engine light to immediately show up. The reality is far more subtle. Ignition coils weaken and spark plug wires lose conductivity over time, reducing the strength of the spark long before a cylinder completely misfires. This partial failure pushes the mixture toward incomplete combustion. That incomplete burn dramatically increases detonation risk. Those dangerous moments when the mixture ignites at the wrong time, producing violent pressure spikes inside the cylinder. Detonation punishes critical components. Pistons crack under the repeated shock, valves warp from heat stress, and cylinder heads can literally fracture. Or at the same time, unburned fuel leaves behind heavy carbon deposits on piston crowns and valve surfaces. These deposits act as hot spots that trap heat, further accelerating pre-ignition and multiplying the damage. Overheating hot spots also spread into the exhaust system, raising gas temperatures, overwhelming the catalytic converter, and stressing internal parts with constant thermal abuse. Engines rarely die from one dramatic failure. More often, they slowly lose life from small, overlooked parts. A $10 sensor, a $20 hose, or a $50 belt can start a chain reaction that ruins an engine worth thousands. The warning signs are subtle, which is why so many drivers miss them until it's too late. So here's the question. Will you take action to replace these cheap parts before they silently end your engine? Preventative maintenance costs pennies compared to neglect. A little attention now saves you from massive bills later, keeping your car reliable and your engine alive. That's it for today. If this helped you spot engine-killing cheap parts, tap like and subscribe for clear, safety-first DIY. Next up, never use these 11 engine oil additives. Don't pour damage into your engine.